Good afternoon and welcome to everyone. Today is part 2 of our professional learning coding series for grades 3-4, our Growing with Code. My name is Nina Nesseth and I am a staff scientist at Science North who will be leading you in this session today. Feel free to drop in the chat where you're joining us from today. In working in the background, I have Max. Hi, Max. So Max is going to be watching the chat today. So if at any point you have any questions, please put them in anytime in the live chat and Max will be watching and answering those questions as we go along. As well, Max will be adding in useful links during the presentation. So keep an eye out for any messages from him. Okay, so before we begin, I would just like to start with our land acknowledgement. We would like to acknowledge that we are on the traditional and ancestral lands of the Atikomishing, Anishinaabeg, and Wanapitei First Nation. We would also like to acknowledge the Métis Nation for their cultural and economic contribution in this area. These lands sit in the Robertson-Huron Treaty area, and as we are all treaty people, it is important for us to all be thinking about what treaty area we live in and are an active part of. So let's take a moment to appreciate the land that we are on by acknowledging the traditional territory and treaty area that you are located in. So this land acknowledgement describes the area in which I am now as part of Science North in Sudbury, Ontario. Feel free to share in the chat where you're coming from and which treaty area you belong to. And as well, before we begin, I just wanted to point to a few resources that we have for you at our Science North website. So at schools.sciencenorth.ca/justteachers, you will find a wealth of resources that are specifically for educators, including links to different professional development series, such as this session today, and resources to support your teaching in the classroom. One of my favorite ones that we've created recently is this Science at Home resource. So it's kind of small, but it's in this sidebar here. And that will lead you to a wealth of resources for grades K-12 that are specifically detailed for teaching virtually or for doing synchronous learning. So these are all STEM lesson plans linked directly to our curriculum expectations for each grade. And they all include hands-on activities that use materials that your students will be able to easily access within their own surroundings in their own homes. So it's a nice way to get some hands-on learning virtually. And as well, all of our resources from today, as well as resources from our previous coding series lessons, can be found at education.sciencenorth.ca. And if you do education.sciencenorth.ca/coding, that will bring you directly to the coding series. You can see also it's this clickable banner piece right here in the top center. So that includes our lesson plans, our handouts, answer keys, as well as recordings of these live sessions. So if at any point you miss a session, or if you want to revisit the material, you can access them for free on this website here. So yesterday we spent some time going through an unplugged activity that allowed us to sort of break down simple codes or simple algorithms and identify repeating steps, sequential steps, nested events, and concurrent events. And today we're going to be spending some time doing an online coding activity using Scratch. Now, before we move into the Scratch lesson plan, I do want to just quickly show a Scratch Junior program that is also included with the programming resources for this lesson. We've had some feedback from a few educators that grade 3-4, especially grade 3s, can sometimes be a tricky spot in terms of where to introduce coding and with which tools to use. So if your students are very, very new beginners to code, or if they're not especially comfortable with written language yet, especially especially with Scratch, there is a lot of text on some of the blocks, then we can do this modified activity using Scratch Junior. So I'll just switch my screen real quick. And Max just added a link into the chat for the desktop version of Scratch Junior, because typically Scratch Junior is an app that you would use on a tablet or iPad. And there is an unofficial version of Scratch that can be used on desktop, which is this version that I'm sharing here. So what we see on screen is an alternative program that you can use with your students as either a stepping stone into programming with Scratch, or for students who are still pre-literate. So this program, if I press my green flag up here to start it, teaches your students how to add elements to code and to create clickable objects on a screen. So this is the end result here, and we would have a sun that moves when we click it, clouds that move when we click it, and a plant that when we click it grows larger. It keeps growing larger every time we click it. So we can still use this program to center a conversation around the needs of plants and the parts of plants, but the coding is very much simplified. And if we click on the different sprites, you can see the code that we've built down here that uses nice big icons and very little language. So if you want to try this one out, I encourage you to check out the resources that we have at education.sciencenorth.ca. And if you have any questions at all when you're testing this program out, feel free to email us as well. So I'm going to switch over again to the end result of what we're going to be building today. So the program that we're going to be building today using Scratch is going to include a little plant sprite that follows the mouse. So you can see when I move my cursor around, I have a little teeny tiny flower that follows it. And when that flower sprite touches water, the sprite gets bigger. And when it touches sunlight, it gets bigger. But when it gets touched by our consumer, our rabbit, it gets smaller. And so this is a very simple base program, and it keeps going as that. It's a very simple base program that your students will have a lot of fun remixing and expanding upon. Go. I'll just return now. So at this point, I would like you to join me at Scratch. So Max has added the link to the Scratch homepage into the chat. So if you open up Scratch, you don't need an account to participate in this workshop and to follow along. Once you open the homepage for Scratch, you'll see at the very top of the screen, there's a button that says Create. And once you click that Create button, it will bring you to the Scratch coding screen, which should look like this. So we can see that we have on the left-hand side of the screen a whole selection of blocks to do our block coding. We have a nice blank canvas in the middle where we can build our code. And we have what's called a stage here where we see our cat sprite, where our code will exist. So we can see the outputs of what we've programmed. At the bottom, we have two other panels. We have one for adding and modifying sprites. So these are our graphical elements like this cat here that we can program. And then we have a nice little panel on the side too if we want to add or modify backdrops. So to start, we're going to start by building our plant. Now, if you've joined us for other sessions using Scratch, typically we go into the sprite library and just choose a pre-made plant. But I noticed that in the sprite library, there aren't a lot of plant sprites. So this is a great opportunity for us to actually go ahead and paint our own sprite. So I just deleted the cat because we don't need it for this program. And I did that by clicking on the icon for the cat and then clicking on the little trash can on the corner just to remove it. And if we go down to this Choose a Sprite button at the bottom of the screen, we can actually select the paintbrush to open the Costumes tab. And this is where we can draw our own sprite. And if you've used any painting program before, it's pretty straightforward. So we can select the paintbrush and we can change our colors using the Fill tab up here at the top of the Costumes tab. And this is a great opportunity for students to try to get their different parts of the plants added. So we can make sure that we have our, our stem and our leaf. And I'm going to draw a flower, but another great opportunity for extension would be to provide your students with a list of different plants that they can then research, especially plants that might not necessarily be familiar. They can be a mix of plants that we might find in our own backyards and plants that we can find in different parts of the world. And then draw our own plant sprites. So I'm adding some roots. And it doesn't have to be beautiful, but it does have to have all the right parts. Go. And you can even get as complex as you'd like. You can make sure that there's a pistil and stamen in there, if that's what we've been learning in class. And also we can use this little fill bucket, of course, to fill closed shapes. I can fill the flower on my plant really easily using the paint bucket and the leaf. And last but not least, I'm gonna just finish up my flower. There we go. And once your sprite is completed, you can just click back over to the code tab if you'd like, if you don't want to have that tab open. I'm going to, in this sprite panel, actually rename my sprite flower so it's properly identified. Now our next step I'm just going to pause for a moment because I noticed that we have some viewers today who are just catching up with Scratch. Now the link to Scratch is in the chat. It will be scratch.mit.edu. And once you reach the home page, you'll click the Create tab at the very top of the screen. Now, if you don't want to spend too much time catching up with drawing your own plant, or if you don't have time to catch up to do that, you can use the Scratch cat as your replacement plant while we practice this lesson. But we're going to move on and draw our water sprite. So we're going to go back into the Choose a Sprite menu at the bottom of the screen and click Paint again. And this will create a whole new painting canvas for us. And we're just going to draw a simple just a simple ellipse here to be our water. And I'm just going to put out a reminder as well that you do not need to create an account to access Scratch. It's free to use without an account. So from the home page, you just need to click on the Create tab at the top of the screen. You don't have to be logged in at all, and it will bring you directly to the application that looks like the screen I'm working on right now. There we go. Now I've drawn and painted my little body of water here, and I'm going to drag it into place. You can drag it into place either in your Costumes tab, or you can drag it up in the stage by just clicking with your mouse and moving it over. And just to answer your question, Nadia, as well, to teach in the classroom, you don't need to necessarily have accounts as well. You definitely don't need a teacher account. Your students can create free accounts, which is useful if you want them to be able to share their work for you to be able to view it. So I recommend to not do the teacher or classroom accounts to do this. I recommend just signing up and using the free accounts that are kind of the general public accounts. And the reason I recommend that is because if you create a teacher account, your students are then locked into that classroom. And so once they end their time learning with you, they can't take that account with them. So they can't continue to build upon the stuff they've created in your classroom beyond your class. So my recommendation is to use just the free accounts if you want your students to be able to save and share their work and revisit it and be able to send links to you so that you can view it. Otherwise, if you don't want to have the if you don't necessarily want to review their work, which I suspect you would want to, then they can just play with it as we are today. Feel free to follow up with an additional question in the chat. I hope that sort of answered your question. At the end of the session as well, I'll double back through the chat and just address anything that we weren't able to address during the lesson. Now we need one more sprite. For this one, for the sun, the sun and the rabbit. So for the sun, we will just go into the library. So the way I did that was to choose a sprite down here. And I'm just going to search for sun, just because it's a little bit easier there. And we'll do one more. So down into my choose a sprite, and we'll search rabbit. It doesn't have to be a rabbit. You can choose a different consumer. But for today, it'll just be a little bit easier. There, so we have all of our elements, and now we can go ahead and code them. So the first thing that I'm going to code is to have our flower follow our cursor as we move it around the screen. Because that's what makes the whole game fun, is that we can move it around without having to click and drag it. So to do that, we're going to make sure that our flower sprite is selected. So we do that by clicking on its icon in the sprite panel. And we are going to go to the yellow events tab here. So this yellow events tab includes all of the blocks that we would use to start a program. And for this program, we're going to grab this very first block that says when green flag clicked, because we want this program to start as soon as we start the entire program by clicking on this green flag above the stage. So the next thing that we're going to do is we're actually going to shrink down our flower because we want to make sure it starts off small so we have room for it to grow. So we're going to go to our purple looks tab. And we're going to choose this set size to 100% block. And we're going to add that and just connect it directly below the yellow block here. So we only have two blocks. The first one's when green flag clicked, and the next one's set size to 100%. We'll change this to something smaller, let's say 10%. If we click our green flag now, we'll see that immediately our flower shrinks down to a teeny tiny little flower. Now to get our flower to follow our mouse around, we're going to have to add a control element. So we're going to go over to our light orange control menu, and we're going to choose this forever loop. So everything that we place inside of this block, inside this little mouth-like space, is going to repeat indefinitely. And that's great because we want our flower to keep on following us over and over and over again every time we move the cursor. So we'll connect that right below our set size to 10%. And then in our blue motion menu, which is the very top coding block menu, there is a block that says, in your menu, it'll probably say go to random position. But if we select the drop-down menu, there's actually an option to go to mouse pointer. So Scratch anticipated that this is a piece of code that its users would probably need to use a lot. So it gave us a nice built-in block. And then you just place it inside the forever loop. You'll notice that when you drag on top, that the loop will stretch to open and fit your block. Now, if we press our green flag and move our mouse around on the stage, we'll see that the flower will follow it around. Oop. So our next step is to have our flower change size when it touches different sprites. So when it touches the water and the sun, we want it to grow. And then when it touches our consumer, our rabbit, we want it to shrink. So to do that, we're actually going to still build in our flower sprite. So make sure we're still clicked on the flower, and we're going to start a new program. So our new program will start again with this when green flag clicked block. So that's in our yellow events tab there. So we'll start a whole new program. And we will need another forever loop. So we'll go over into our control menu again. So that's the light orange one. And we'll grab a forever loop. And the rest of the program we're going to build inside this loop because we want our flower to be constantly checking to see if it's touching the water or not, or touching. Let's start with the water. So every time it's touching the water, we want it to grow. So we want it to be constantly checking. We don't want it to check just once. So now we need to program our condition for whether it's touching the water or not. So we actually have to nest a control structure inside of the forever loop. We practiced nesting a little bit yesterday with our classroom activity, but we did it only with loops. We didn't use any conditional statements. If you want further practice with conditional statements at a grade 3-4 level, I really recommend the lesson Gears Rule, which is listed currently on our education website. So that one goes through a lot of good activities that have to do with conditional statements. All right, so from the control menu, I chose this if blank then block. And I'm going to place it right inside the forever loop. Actually, I'm going to take it back out for a second just so we can see it a bit more clearly while we set up our conditions. And I'm going to make this a little bit bigger so we can see the blocks more closely. Because we need to fill out what that if is, and then the output will be inside the mouth. So our condition is answering the question, is the flower touching water? And to do that, we're going to go into our light blue sensing tab. And at the very top, you'll see a block that says, is touching mouse pointer question mark. And using the drop-down list, we can actually, see, this is why we should rename our sprites. So sprite 1 is our water. So if I actually go over to my sprite tab, and I renamed my flower, but I forgot to rename my water. So using the naming field here, I renamed my water. And now if I go back to my flower sprite and select the drop-down menu on my sensing block here, we'll see now that we have the option for water. So it's always recommended to name your sprites so that they're easier to identify when you're doing your coding. Now you'll notice that my sensing block, when I drag it on top of that shaded hexagon-like shape, that it highlights. And if I drop my block on top of it and let go of the mouse, the block will stretch to fit that shape. So that's our condition. Now, what do we want to have happen? We want our flower to get bigger. So to do that, we're going to go back into our purple looks tab. And we're going to choose this change size by 10 block. And you can change the value on this block. Let's start with 10 just to say. And now we can put it back into our forever loop. There we go. So if we test it right now, whoo, we'll notice something really interesting happens. And I did that on purpose so I could demonstrate, is that because our forever loop is cycling very quickly to check if the flower is touching the water, it's answering the question, is the flower touching water, very, very quickly. So basically, as soon as your flower touches the water, our code, which is looking for the water, is answering yes lots and lots of times really fast. So yes, 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 and our water gets really big really fast, or our flower gets really big very fast. So the way we can control this so that it grows a little bit more slowly is by adding a wait block. And wait blocks are very handy when you're working with loops in general and with conditionals, just because it allows you to have a little bit more time for your program to reset itself. So in the control menu, the very top block says wait 1 second. And if you place that inside the conditional block, right under the change size by 10 block, then that should give our program enough time to sort of reset itself before it checks again. So if we press our green flag now and test again, we can see it still grows while we're touching the water, but it's at a much more manageable pace. Now to do this for the sun, we can actually modify this exact same program. First, we want to copy it though. So if you right-click the very top block of whatever piece of code that you want to copy, so in this case, I want to copy the entire code, so I'll right-click on the very top block, I get the option to duplicate. And when I do that, I can just drag and drop and have 2 copies of the same program. And all I have to do is, on my sensing block, choose the sun instead. Now let's say our plant grows a little bit faster when it's exposed to sunlight. That's how it's going to make its nutrients in its leaves. So now, I changed my size to 15. You can try experimenting with different values and encourage your students to experiment with different values. So now when I touch the water, my plant grows a little bit. And when I touch the sun, my plant grows a little bit faster. And when I touch the rabbit, nothing happens because we haven't programmed it yet. For our last element, we can do the same thing again. We can actually copy our program one more time. So if we right-click on the top block of our program and duplicate it, we can have a third copy of our changing size program, and we can select rabbit this time. Now, the change size block controls the size of our plant and how that plant size changes. And we know how to make the plant get bigger. So what do we have to do to try and make our plant get smaller? Now, your students might not have had any exposure to integers yet, so we'll have to show them that adding a minus sign or a negative sign before the number will make the plant get smaller when it touches the rabbit. And we can say negative 15, or we can say negative 10 just to say. So we're starting with our tiny plant. If we go directly to the rabbit, it does in fact get even smaller. And if we go to our water and our trees, or our water and our sun, it gets bigger. And if we go to our rabbit sprite, it gets smaller. So this is a really fun base program. Students will have a lot of fun figuring out how big their plant can get. And usually it stops somewhere around 200%. Let's see. I think it's fun too. Oh, it's pretty big. They might also notice that when their plant gets big enough, it can touch maybe 2 other sprites at the same time. So let's see if we can get our plant touching the rabbit and the water at the same time, and you'll notice that it starts moving back and forth between its size changes. And so they can spend some time debugging their program, seeing if they can make some changes to adjust for that. Some other opportunities for extension, obviously, students can experiment with adding complexity to this basic program by adding backdrops or adding other elements to further simulate an environment and the different factors affecting our plant in this environment. Since we've basically learned a few ways where we can have these factors interacting with each other, it's not too much of a stretch to add complexity in that way. They can also see if they can figure out how to get, this one's a little bit more advanced, but how to get their plant to change size when only certain parts of it are touching other sprites. For example, when the roots are touching the water. And that would involve experimentation with these touching color blocks. So for example, there's a block here that says when one color is touching another color here. And we could experiment with replacing our touching water block. This will involve knowing exactly what color your roots are, but there is an eyedropper tool. So if we make our flower a little bit bigger first, we might be able to sample the color from our roots to that's big enough. One of the challenges, though, is that it's hard to take my mouse off of the screen. There we go. Ah! And stop this in place. So there are a few fun little debugging issues here. One involves the fact that I set my size to 10% every time, or that my mouse is following me to a corner, so I can't find my flower when I'm done. So now I'm just fiddling, but you can see how there are ways that we could expand upon our program. So what I've done here is I've just disconnected. I've disconnected my program here just to be able to access the eyedropper tool. And now I can use this little eyedropper button and click on the color I want. So when this color is touching this color. Now let's see if this works a little bit better. So to get rid of the set size to 100, reconnect everything. And to start my program anew, let's see if my plant grows. Yay! So when my roots are touching the water, it works. But if I'm only touching with the flower, which is not that brownish color, my plant doesn't grow. Now to answer the question, do you always have to click on the green flag and what is the stop sign for? So those are great questions about Scratch's function. So do you always have to click the green flag? Yes and no. We have to click the green flag for this program because we set the green flag as the start button for all of our programs. If you go into the yellow events tab, you can see that there are different ways to start your program, such as when a sprite is clicked. So I could set it so that when I click on the sun, the program starts, or when I press spacebar, it starts. But I've set my program to say that when I click this green flag, my program starts. And the stop sign is for stopping my program. Because sometimes if you leave your program running and go to continue building while it's running, it can sometimes be a little bit distracting to you or your students, or sometimes confuse some of the work that you're doing. It's a lot easier to stop your program and then build and then restart it again. Especially since some of the elements that we're programming only initiate when we start the program. To really see if they're working, we often have to stop and restart. Now, one thing that I didn't mention is that you can actually start individual sections of your program. Because right now, because all of my programs, so I've created 4 programs for this lesson, and all of them start when I click this green flag. So when I click this green flag, I start all 4 of them at the same time. But say I wanted to just start one of those programs. Here, I'll just grow this for a second. Say I just wanted to start this one program here. If I just click on that program only, you can see that there's a yellow border around it. And so I have this little tiny flower that's following my mouse around, which is exactly what that program says. But if I touch the water or the sun or the rabbit, nothing changes in size. So my sprite doesn't change in size because I've only activated the one program, which you can see by that yellow outline. If I press the green flag, you'll notice that there's a yellow outline now around all of my programs. So now when I move my sprite to touch the different elements on my screen, we get the size changes that we programmed. So because we've set our program up this way, yes, we do need to click the green flag. I recommend for beginner coders to start with programs that start using this green flag. It's a nice, easy, global way to initiate your programs. But once your students become more comfortable with programs that can be initiated in different ways when different elements are clicked, then absolutely I encourage you to experiment with these different pieces and see how they work. You can check out some of the other lessons that we've already delivered for grade 3-4. I believe all of the lessons that we've coded use the green flag to initiate the programs, because at that grade level, the green flag works best. But if you're curious, you can definitely check out some programs for older grades. I know for sure some of our grade 7-8 programs use other elements. I'm a little fuzzier as to whether our grade 5-6 ones do. And so this is our basic program. Very, very straightforward in terms of the programming elements, but very easy to expand and to bring into a lot of different examples. Could you please share a math or algebraic equation example? Very interesting. So if you want a really in-depth lesson that looks at math examples, I recommend checking out the grade 3-4 program called Transformations. It does go into basic transformations. So we do reflections, translations, and rotations, and we use a lot of these operator blocks here. There are 2 versions of that lesson plan. One that's a little bit simpler for students to follow, and one that is a little bit more complex for students who are more comfortable with the programming pieces. I'm trying to come up with an idea for adding some operators off the top of my head. So we can say something like, I probably won't use an algebraic equation example for grade 3-4 because adding, like in terms of adding like variables and those sorts of elements, that's a little bit advanced for grade 3 and 4. Again, I recommend checking out some of the older grades for that, but we can add some operations for sure. So let's say, let's create a quick program where something will happen if our flower gets a certain size. So this will be using greater than, lesser than, rather than, standard operations, but just an example that brings a little bit of a stronger math tie. The algebra curriculum link for this program is in fact the coding, which is our C3 algebra curriculum piece. But just to bring an expression in, we will use this greater than 50 block. So let's create a quick program. We'll start again with the when green flag clicked. And we will add this wait until block. So this says that our program will wait until our sprite gets to be a certain size. So let's see if we can do this really easily. Ooh, we might not be able to do this easily because I don't know if there's a block for our sprite. Ooh. Ah, size. So I found the block that I was looking for. So if you go into the purple looks menu, at the very, very bottom, there is a block. And if we actually check the checkbox next to it, it will bring up a counter that on the screen that will tell us our flower size. So let's say, and if you take that little size piece and drag it on top of the first space on our operator block, we now have a piece that says, wait until our flower is bigger than 50. And we know that our flower starts, let's see, what size does it start at? It starts at size 10. So we have a program that will trigger something when our flower reaches size 50. So let's say we'll have it change colors. And we'll make that into a loop just so that it changes colors a lot. So let's say forever change color effect by 25, and we'll put that just inside there. So now we're including a little expression in here. And we have our flower. We'll make it bigger by adding it to our water here. And now it is larger than size 50. And we can see that it's changing colors very, very fast because it's triggered that change color effect once it's gotten larger than 50. So this is a very simple expression. It's what I could sort of come up with off the cuff. However, if you'd like to explore more ideas for how to make, how to add these operator blocks in, if you feel your students are ready to play with these green operator blocks, please feel free to send us an email. I'm actually going to move to my end of lesson housekeeping because I know we're running a little bit long. Feel free to send us an email at educators@sciencenorth.ca. Thank you, Max. We have a team of Bluecoats who are there to answer your questions and to help you explore these options. We can even schedule one-on-one sessions with you to explore different coding elements. Whether you're just starting with these tools and trying to familiarize yourself with them, or whether you're looking at how you can explore these tools further. I'm just going to close my Scratch screen and answer a few of our remaining questions. So I noticed that we also have a question, is Science North going to continue these coding lessons for teachers? We may be continuing some in the future. At this time, this series will be ending with this sort of cycle of lessons. We have, after today, one more. Next week, we're doing grades 5, 6, and following that, we're doing grades 7 and 8. There is a possibility that we'll be launching a fresh series in the future, but there will be a little bit of break at this point. However, using us as a resource, as Max has mentioned, is always an option. So this email, educators@sciencenorth.ca, is where you can access us as resources to help support you. The resources that you've been seeing so far, this would be our third grade 3-4 lesson that we've gone through with our live sessions. All of these resources will continue to live on the education.sciencenorth.ca website, so you can continue to access them and revisit them in the future for free. So as Max said, if you aren't already signed up for our teacher newsletter, I recommend signing up, because then you can be in the loop if and when our coding series as a professional learning series starts up again. And last but not least, and great question about creating coding videos for students. Typically for our student pieces, we prefer to do that as like our live engagement. And there are some classroom lessons that already exist if you check out our website, where we can actually have a Bluecoat joining your classroom for some virtual coding. Or if you're in the area, once everything's reopened again, doing some coding lessons on site. Before we go today, of course, we have our survey before you go, if you have a moment. And as well for the comment, I believe there is a question in the survey as well to say yes if you'd like to be added to our newsletter link. If not, they should be in a follow-up email as well. We do miss students on site. And your feedback is super valuable to us. It allows us to know what's working for you and what you would like to see in the future. And it sounds like you have some really great ideas in the chat of how we can further help you. So please let us know in the survey, give us that feedback, and we'll be able to use that to continue to offer you great materials. And that's it for me. I am going to sign off the live video, but I do see a few other questions about how to sign up for live sessions, so we will just follow up in the chat at that piece. But I want to thank you all for joining us today, and I hope you have a great evening.